give you a sense of how things have accelerated. He tells me that when he joined, Facebook had 10 million people. Roughly 10 million people. Today it has over 1 billion. I don't know how many services it had, but it had a bunch more. How many employees then and now?
About 120 to over 5,000.
From 120 to 5,000 employees, so 100-fold on the front end and, what, 40 or so?
Yeah.
42 times on the back. So we're about to do big data complexity on a whole new scale. Let it rip, Michael. Thank you very much.
Thank you.
Yeah.
How about now? Good? Okay, terrific. Hey, Mark.
Can you guys hear me? Yes. Great.
All right, great. Thank you all for joining us. We're the ones who are going to keep you from lunch, but we're going to go from death to life here. We're going to try to follow a couple of parallel tracks here. Itamar was one of the very first data scientists hired. Were you the first one?
I was the first data scientist.
So Jeff hired
Facebook,
you, right?
Yeah.
So we're going to both take a little bit of a path through your history and then parallel the history or the timeline, as we cleverly decided to call it, of data science at Facebook. So why don't we get started? Let's start at the very beginning. So where'd you grow up, and what was your academic background?
Yeah. I was born in Jerusalem, actually, and immigrated with my family to the United States when I was 6 years old. I grew up in the Midwest, Cincinnati, Ohio, go Reds. And went to Stanford University upon graduating high school. I chose Stanford for two reasons. Number one, I was really interested in a major...
You know where we are, don't you?
Absolutely. My apologies, everybody.
Sorry.
But I'll explain. Stanford has a major called Symbolic Systems, which some people in the audience may have heard about, which essentially is a combination of cognitive science and computer science, which was very, very interesting to me at the time when I was 17, 18 years old. You know, the prospect of studying philosophy and psychology and statistics and artificial intelligence, I just never imagined that would be something I could do in undergrad. And there was another program geared towards freshmen called Structural Liberal Education, which is sort of a great books program. And both of those things just seemed immensely appealing to me, so that's why I went to Stanford. It's kind of interesting. I bring up the two programs simply because I think a theme of the time I spent there was very much trying to capture a bunch of different disciplines at once with sometimes mixed results. But perhaps that led to data science, which really is a mixed discipline, being something suitable for me.
So you graduate, and then what's your path to Facebook?
So actually, there's a couple of interesting things that
right?
I did, yes,
okay,
but
good.
There's a couple of interesting things that happened along the way. In Symbolic Systems, I focused on artificial intelligence, and that ended, and I sort of thought to myself, I'm missing something. It felt like I was missing something concrete. And actually, I think what I was yearning for was just some education in the social sciences. So I went and studied economics, focusing on econometrics. And then I felt like I was missing something again. And what I ended up doing was a master's program in symbolic systems, this time focusing on experimental linguistics, where I was running experiments in a lab. Mm-hmm. So sort of had a bunch of experience with statistics and computer science, and then social science, and then experiments, and imagined I'd have a career in academia, but had no idea where to go. And at the time, I was living with some friends who were a few years older than me, who were very, very early employees at Facebook. While I was doing my coursework for my master's, I was sort of observing all of these guys having an amazing time building this increasingly important service that was part of my life from the ground up. Incidentally, when they had just started working there, a few of us who weren't working there were sort of just laughed it off. Like, what are you guys doing working for Facebook? You know, do people actually work there? Isn't it just a couple of guys? But you know, over that year, it just looked increasingly awesome. You know, they would come over and push code from my living room every once in a while, and that was just kind of cool to see. So it just seemed increasingly attractive. So I went and applied as a software engineer. Did a couple of interviews there. And I knew Dustin Moskovitz, who was the co-founder socially, from the fact that he was friends with some of these people I lived with. And he actually, through knowing me and through knowing my background, sort of had the idea that I would actually be a better fit in this new role called data scientist that Jeff Hammerbacher had just decided he wanted to hire for. So that's a lot of serendipity there. But somehow he connected me to Jeff Hammerbacher. Jeff and I had lunch, I think, where we talked about philosophy and experimental design and math and some really high-level stuff. And then he gave me a homework problem, which was essentially...
Do you remember what it was?
Yeah, it was design a system for optimizing invitations for registration for a website, which I ended up doing a lot of work on once I joined.
Yeah.
So it was basically like a homework problem where I wrote a paper of how I would methodologically approach this, and then I started.
Yeah.
Yeah.
So you arrived at Facebook. What are your tasks when you arrive? What does it look like in Facebook?
Yeah.
Both architecturally as well as organizationally.
Yeah, totally.
Yeah.
So I arrive at the beginning of January, pretty much the first day of work after the new year in 2007. This is 2.5 months after Facebook opened to the world. Prior to the end of September, we were a closed service where you had to be part of an authenticated network to join. So, a college network with an EDU address, or a high school network either with a high school email address or some other social verification system, or a corporate network, although not very many people were using our corporate option. So at the end of September, shortly before I joined, we opened that up, and essentially the project was called Open Registration. Now anyone in the world with an email address can join and have an account. And that meant that the main focus was growth, was user growth. At the time that I came, since it had been a couple of months already, we were starting to ramp up on users. And the main focus of the company was building a stable product, making sure that our systems are stable and that our website wasn't falling over, and just increasing our user base to essentially provide a service that was useful for the world. That was the focus on scaling the product. There was very, very little sophisticated infrastructure in terms of analytics and reporting in place. Jeff had spent a few months with one or two other folks putting in the bare minimum. So when I got there, I think we had most of our historical data. I can't remember if it was a single Oracle machine or an Oracle rack, but regardless, just at most a few Oracle machines where we were storing all of our historical data. And some really, really basic reporting about how many users we had, but really nothing more than that. So most of my focus in the beginning, during those first few months, was going to be on building out our reporting and analytics around user growth. But actually, I spent at least half of my time in those first few months doing something else entirely, which was being a software engineer working on the product. Which is kind of interesting. Jeff was very insistent that I would spend at least part of my time actually working with the product engineers on the product. My actual very first task at Facebook was fixing a bug on the poke feature. And I had done very little web development at the time. I didn't even know what Ajax was. But that was what I ended up doing. And actually, over the next few months, I spent about half my time doing analytics, focusing on growth, which I can talk more about in a little bit, but the other half of my time essentially doing product engineering.
Why did Jeff want you to do that? Because you can imagine him saying, look, I want this guy doing data science all the time.
Absolutely.
Why is he playing around with
the
poke function?
He never really told me, which is kind of his style. I thought it was hazing at the time, but I didn't. I think it's pretty obvious that the reason that he thought it was important, not just for me, but for all of his hires, to be sort of hybrid scientists, engineers, is because if you're going to do science and analytics, there's a lot of engineering involved. A lot of people talk about data science as, a large chunk of it is data munging, is actually data preparation, which requires engineering skills that traditionally things like statisticians wouldn't have. So that's definitely one reason why engineering skills are important. But there's another reason, which is you need to understand the system that you're studying and the mechanisms that collect the data from the system that you're studying, the microscope, so to speak. And in the case of a data scientist at Facebook, that means understanding the website itself, which is essentially the system that I want to study, and the processes that collect information from that website and put it into some area where I can actually do my analysis. So I think that was his reasoning. That's how I make sense of it, and that's what I got out of it. So that was, in addition to the poke feature, I spent a lot of time actually doing development and fixing bugs on the registration system, and on the invitation system. And I think that was primarily the value there was I really got a first-hand glimpse of how this system that I actually ended up spending a lot of time analyzing and optimizing worked, since a lot of my effort during those first few months was, as I said before, trying to understand and optimize growth.
So what about data science? So when does that come into play?
Yeah, sure. Yeah. So I can tell a little bit more about how data science evolved here. So for me personally, the other half of my time, like I said, was spent working on growth. And I started first with just descriptive analysis. So my first data science projects during the first couple of months were essentially growth reports, where that's what we called it. Every week, I would essentially tackle some new aspect of how our user base was growing and make a paper out of it. So the very first thing that I did was, at a macro level, did some analysis to describe how we were growing across all of our various markets now that we were open. So which countries were we growing well in? Which countries were we saturated in? How did the friendship networks appear in various types of markets? What was historically the typical kind of growth pattern? So you'll see an S-curve. I essentially showed that was exactly what was going on. And the idea was to describe to the company, in a way, give us a way of visualizing which markets we were doing well in, which markets we hadn't cracked at all, in the sense that they were dormant, and which markets were sort of hitting the hockey stick where we wanted to put more and more effort on optimization.
And what tools are you using to do this?
At the time, so I was using Oracle, I was using R, Excel in some cases, and Python.
Mm-hmm.
Yeah.
So how did things develop beyond that?
Yeah, so, I spent some of my time sort of on the macro questions that we just discussed, and some more of my time on more micro questions of helping specific teams do optimizations. So what's commonly called as A/B tests, we're just sort of developing here at the time, just to begin with, at Facebook. And most of the A/B testing efforts were around, like I said, growth. So I spent a lot of my time working with the nascent growth team on optimizing our invitation systems, our registration flows, so on and so forth, to actually design the right A/B tests and optimize them as appropriate. So let's take a step back beyond just the work that I was doing here. At the same time, Jeff spent most of his effort building out this data team. It wasn't actually called data science at the time. Mm-hmm. I don't think he brought up the term of data science until the beginning of 2008, and this is still 2007. He spent most of his focus on the data team actually on the infrastructure side of things. So I described how I was dealing with this Oracle database. It was unwieldy. It was impossible to do anything there. I remember trying to run a query over a raw data set that contained all of the pages that people viewed in a given day, where I was trying to do something basic, and it took 30 hours or something like that. So it just the data infrastructure that
30 hours to analyze 24 hours.
Something like that. Yeah. The infrastructure that we had in place just wasn't scaling to the obvious needs that we were just starting to have. So he put most of his effort into developing a new infrastructure, and this is where Hadoop and Hive and Facebook's use of MapReduce came from. So he mostly hired senior backend engineers and senior engineers who worked on things like Oracle to actually come in and develop our Hadoop installation and build Hive, which is our open source sort of database abstraction on top of Hadoop, and various other tools, just to enable the company to have the basic machinery to scale out its use of collecting and using data. Mm-hmm. Data science lagged a little bit from that. I think his reasoning was, let's get the infrastructure in place, and then we can start focusing on building out our data science capabilities. But by the end of the year, there were probably 4 or 5 of us, and by the end of 2008, it was probably on the order of 15. And the flavor of the data science team ended up being with a pretty heavy tint towards social science. Mm-hmm. So actually, data science at Facebook isn't just concentrated on this team that I'm describing. It's a distributed function. So we have data scientists on specific engineering teams working on ranking systems. We have data scientists who are doing some of the more operational business analytics of just working with teams to help them identify success metrics and dig into when something goes wrong. the data science team that I was on was essentially developed into an applied research team of people with various backgrounds: computer scientists, social scientists, statisticians, network scientists. But there was a really strong social science bent there, and our main focus was essentially working with all these product teams that developed at Facebook for, timeline and newsfeed and photos, so on and so forth, to identify really important research questions that they wanted to answer that typically would affect their strategy, and then going off and answering them.
I've heard Jeff say one of the hardest things for a data science team is to prioritize, because everybody wants you. So how did you think about figuring out what problems you all were going to work on?
So I think the fact that the vocation of data science is distributed in the company as the way that I described helped that, because our role became a little bit more clear in the sense that we were tackling sort of applied research strategic questions as opposed to trying to field the day-to-day needs of every product team, or like the ranking and productionalized data science needs of every product team. So we had sort of a luxury of working with the decision makers to identify strategic needs. I think the difficulty in prioritization was not so much that a bunch of people needed us for all these different things. We had a nice focus. I think the challenge was making sure that we were always identifying the most important strategic questions to answer. And that's something that an executive can't necessarily just give to you. That's one of your values as an applied researcher, is you help generate the ideas. So it's an art more than a science, I'd say. It's basically
data art, maybe.
That's right. Yeah. I'll give you an example of something that we did. So in the beginning of 2008, after this year of amazing growth, user growth, we were starting to observe some slight cracks. Namely, we were observing that users who signed up were not remaining engaged in sort of the same rate that we had expected before. And this is perhaps unsurprising, because if you consider that standard S-curve of technology adoption and diffusion of innovation, the people at the top of the curve are going to be later adopters who may be less receptive to the product, less likely to find value in it, so on and so forth.
How do you measure engagement?
That's a good question as well. You can measure engagement in a bunch of different ways. That brings up actually a really good point, where at Facebook we don't have one particular measure that we optimize for. And it's actually been a challenge for us, and I think one of the reasons why an applied research team is necessary and is really valuable. It's been a challenge for us to come up with measures that really are holistic and are ones that we can sort of go to as the source of truth of what we want to optimize. Because essentially, our goal is to make a service that is as useful as possible for an entire network of people of the world. We want to make as useful a social utility as possible. So by engagement, really what we are interested in measuring is some measure of aggregate long-term utility. How useful, how delightful, how valuable is this service, not just to you, but to you and your friends in the long term? And that's not something that you can always directly measure with immediate short-term behavioral signals. So the sort of more traditional Web 1.0 metrics like page views, not great. We look at things that are a little bit more nuanced than that, like time spent, the number of days, or basically just the frequency and rhythm with which you come to the site, the extent to which you produce content and consume content. Basically, just measure the basic properties of how you use Facebook. But we don't have a single sort of composite metric that we combine all these together to say, this is our measure of utility, this is our measure of usefulness. That would be a simplification that we're not comfortable making at this point.
So wait, you see engagement starting to maybe plateau. And
so this was likely a result of the fact that we were just saturating in some markets, and the mix of people we were acquiring were different than before. So this really puzzled the company and was troublesome, and sort of illustrated a really appropriate place where this applied research team of data scientists could come in. So Zuck approached us and said, guys, we're observing this trend, and we really don't know what's going on, and it would be helpful to understand the mechanism so we know where to prioritize.
How important is it that Zuck cares about data science?
Incredibly important. especially from the perspective of this charter of an applied research team that I'm describing, where oftentimes we're working on applied research problems that are of strategic importance. The value of that work is not going to be realized. It's not going to be applied unless it actually affects strategy. So you need the decision makers, Zuck being at the top, to fundamentally care about using research, using empirical methods to help shape and inform how they think. So it's really, really important.
Okay. So he comes in and he says, look, what's up with engagement?
That's right. And we go off and essentially, I'm not going to get into the details too much here, but we go off and brainstorm some hypotheses. We encode those hypotheses in some measurables, and we essentially run a study to find out what's going on. And we focused mostly on what gets new users to be engaged. And the result that we found a bunch of interesting results, but one of the results that we found that was perhaps most impactful is that, and this is pretty intuitive, but what seemed to matter really strongly for whether a person in their first few weeks was going to find the system valuable and was going to start participating was whether they were observing their friends around them doing the same thing. So we had this hypothesis of social modeling, where really our hypothesis was a strong mechanism that gets people to participate is if they see their friends participate. And we have this wonderful way of demonstrating for people what their friends are doing called the newsfeed. So we essentially hypothesized if people saw via the newsfeed that their friends were avidly participating in Facebook, then that would lead them to be more likely to be stronger participants later on. And we actually, through some observational studies with some controls, we were able to demonstrate the validity of that hypothesis. And that had a bunch of influence on how Mark was thinking about the newsfeed in general. So a few months later, we played around with a new version of newsfeed that essentially made the rate of content that the newsfeed displayed for people much higher. So whereas, from the beginning of the newsfeed at the end of 2006 until this point in 2008, the newsfeed was mostly a static, highly curated demonstration of what your friends were doing. That probably changed on the order of a few hours and only showed just bits and pieces. So a couple months after we had this result, and this wasn't the only thing that inspired this change, but I think it had some strong influence. The newsfeed team started playing with a completely different approach, where essentially we show you everything that your friends are doing. It's essentially more of a fire hose rather than a neatly curated section. And over time, we've sort of struck a balance between that. So now we have a newsfeed that's curated but still fast-paced and still really rich, as opposed to the more static version in the past. But the thinking there was really, really strongly based on this finding and this intuition that we want to show you that your friends are doing a lot of stuff. Your friends are having really rich interactions with each other through this social medium, so you should too.
So what does data science look like now at Facebook?
Yeah. Kind of like what I was describing before. Yeah. I mean, it's still an applied research team. Again, the emphasis is on applied, where most of the questions that we focus on are high-level strategic questions that are important for the rest of the company.
How many people would you describe as data scientists in the organization?
In the company at large, I don't know off the top of my head, but it's on the order of, I think, at least 150. But like I said, this notion of data science is embedded throughout the organization. The data science team, this applied research team, is a fair bit smaller. It's about 20 people. So it functions in this applied research strategic analysis sort of way that I described. But there's another function there too, which is historically it's sort of been like a nest egg for budding projects that then go off and become individual teams. And most of the time, the projects that end up spinning off are projects that are a little bit more engineering driven. So I'll give you an example. There's a ranking system that we have for trying to predict which people you should most likely be friends with. It's called People You Might Know. We show you these recommendations for friendships on the right side of the homepage. You guys probably have all seen this, right?
I mean, so, Facebook friends.
That's right.
As opposed to people you should meet and become friends with.
That's right. Yeah. That's right. Now, that actually started as a data science project as well. It was something that an individual on our team who had a background in machine learning and optimization and ranking systems sort of played around with and developed, and it ended up being really, really successful and really, really important in just the growth of our service and our quest to make a really, really engaging product. So that spun out and became its own team. As another example, we had a project on the team many, many years ago where we were playing around with ways to clean up the graph on Facebook of non-people entities. So essentially, we have this graph of what we call pages, which are local businesses, brands, celebrities, those kinds of things. And we want to have as rich representation of that as possible. The problem is there's all sorts of information retrieval and data cleanup problems associated with making sure that that graph of non-people, that entity graph, is really high quality, is really robust. And it means like being able to label authentic individuals, do named entity recognition, do deduplication, puts various classifications and categories on the relationships between these entities. It's a really rich information retrieval problem, which started, again, as sort of a pet project on data science and ended up being really, really valuable and really, really necessary, so it ended up spinning off into its own team.
How's the team organized?
In what sense?
Is there one manager? I mean,
so
Jeff's left the company now. He's a co-founder of Cloudera.
So this applied research team is one manager, and then the scientists themselves typically work in pairs or groups of 3 and 4 on some area. So we've found that it's the way that we most efficiently interact with the company to identify and then tackle strategically important questions is by having groups of people that are dedicated to a particular area or a particular set of questions on the company. So as an example, there may be a particular set of people dedicated towards understanding and working with the teams that develop our distribution channels, so newsfeed, notifications, email, so on and so forth. There may be a group of people that's dedicated towards tackling questions around communication, so our group's product, our messaging product, so on and so forth. So we organize thematically in this sort of manner. Usually, it ends up being around people with a particular expertise are going to gravitate towards a particular set of questions, and then typically there will be one person or a couple of people from that group who work with the appropriate product team and foster the relationship with them. That enables us to develop the right sort of strategic questions that are most important for the company.
And what does the analytic technical infrastructure look like nowadays?
Yeah, so much, much more robust than before. As I described a couple of minutes ago, our main focus from an engineering perspective as a company with respect to data science has been to make sure that the company has the necessary machinery to use data. Data scientists, the data science team that I described is not the only set of people who are using data. Data scientists throughout the company as well are not the only people who are using data. There are all sorts of analytics needs that business analysts and data scientists and engineers are doing on a day-to-day basis. We probably have more than 1,000 people doing analytics on our data infrastructure on a given week. I'm just guessing, but I'd imagine that it's roughly on that order. So it was really, really important for us as a company to invest in the machinery to make this happen. Invest in the machinery that actually enables this really robust and large growing organization that's hungry to use data to be able to do it, mechanically speaking. So the biggest part of our data infrastructure is a Hadoop instance with Hive on top of it.
Are you a Cloudera customer?
We're not. So we have our own Hive branch that we use. Essentially boiling down to the fact that we have a bunch of unique needs that the open source project right now doesn't have. Don't know too many of the details on that since I mostly focus on analytics rather than the nitty-gritty of the infrastructure. So we have this Hive instance, which is the main thing that we use.
Can you give any dimensions around it?
Yeah, I'm just thinking exactly how much it is. It's on the order of a couple hundred petabytes. I don't know the exact number, but yeah, it's quite large. Exabyte scale is what we're calling it. And that functions as our main historical data warehouse. It's where we keep all of our historical records of all the key information that we might want to use analytically. On top of that, we've been playing with a bunch of really interesting technologies for making use of that data infrastructure easier. Because Hive and Hadoop and MapReduce are great for addressing this need of really large-scale storage and analytics. But the problem is they're not always that user-friendly. It's long been an issue at the company, and I'm sure other places that are using MapReduce at that kind of scale, that you as an analyst or a data scientist may have a series of questions that you want to ask interactively. You don't necessarily have this programmatic routine that you want to just fire off and run on a daily basis. Maybe you're just starting to get to know a data set, and you want to do some exploratory data analysis, do some quick summarization, try a couple of things out. That process is interactive. But the problem is, if you're dealing with a really large data set in this infrastructure, that interactive process can grind to a halt because you're waiting minutes, in some cases hours, for your results to come back.
It feels batchy, right?
It feels really, really batchy, because that's really what this infrastructure is most appropriate for, is batch processing. But it's where all the data is, so interactive processing is also done there. So there's this funny thing that happens with data scientists in this environment where they become really good multitaskers. Because you get used to this process of, I'm going to be interactively querying, but I'm going to be waiting, so I'll go write an email, or I'll go work on some more mature data that I'm processing in R, and sort of have to keep these multiple contexts in my mind where I'm switching back and forth. So we've focused more recently on some things on top of Hive to make that easier. But we also have an alternative data infrastructure that I think I'm at liberty to talk about this. This is a paper in VLDB this year. So we have an alternative data infrastructure that is much, much more geared for this interactive query use case. And it's essentially a distributed in-memory infrastructure. So there's a bunch of limitations to this infrastructure in the sense that the data is not guaranteed to be persistent. So it's not good for historical records. It's not good for batch processing. You can't do joins. But it has just blazing fast aggregations. So typically, if I'm a data scientist or an engineer and I want to sort of just start to play around with some data, I'll instrument it from the front end to go straight into this in-memory system where I can do like slicing and dicing, essentially. Lots of group bys and aggregations and time series graphs in nearly instantaneous fashion.
Open source or not?
I'm not sure.
Okay.
It's a good question.
Yeah. Terrific. And what else have you been working on recently? My understanding is you've had a new focus.
Yeah, absolutely. So as I was describing just a couple minutes ago, most of our efforts as a company, our engineering efforts, have been on the underlying data infrastructure. Essentially, as I said, arming the company with the machinery to just deal with this volume of data, to store it and run computations over it. And the culture at Facebook has been one, from the beginning and until now, of moving fast. So we really, really strongly believe that every product team, every team that's building something or trying to get something done, should be armed with being able to get everything it needs to get done on its own, which is sort of one of the reasons that we invested in this underlying infrastructure. So, the photos team, if it had some analysis to do, can use a common infrastructure to do that. And the timeline team, so on.
Do you still say ship and break things?
The phrase was move fast and break things. We've shied away from the break things part of
just part move fast, no breaking.
Move
okay.
fast, yeah. I think it's the break things phrase is meant to stress the fact that we want people to be bold. So now we say move fast and be bold because we don't want to break things. It's actually interesting. I mean, once you become a really rich, interconnected organization, if you break things and if you don't invest in reliable infrastructure, you actually can't move fast. So it became not very appropriate to talk about breaking things as much. Anyway, so like I said, we invested in this infrastructure that gives people just the machinery to do what they want, and all these teams are sort of going off on their own, using data, defining their own success metrics, collecting the data that they need, running A/B tests and experiments, building machine learning and ranking problems on top of this infrastructure. Everybody's sort of doing their own thing. Meanwhile, there's this applied research team that's thinking big picture about what the most important analytics questions for the company are. But along these lines, no one ever really thought to make sure that there was the tools and infrastructure on top of our storage and computation system to make sure that the way in which all of these teams are using data is standardized and as efficient as possible. Actually, what they were trying to use the data for is in some ways scaled. So I'll give you some more specifics about that. So, number one, historically, the way that people have gotten data into this Hive system is an engineer has something that they want to record, so they just, in PHP, in the front-end code, log some data, toss it over the wire, and don't really think too much about the format of how it looks like. These teams have very specific metrics that they optimize for that may not always map to global metrics that we care about as a company. And these teams are often doing things that are highly redundant to each other. So for example, everyone's running A/B tests in order to use data to make decisions. But in this environment that I described to you, where every team is sort of moving fast and doing their own thing, there's some redundant work and there's some lack of consolidation. So even though everybody's doing A/B tests, people are building their own systems for evaluating them that duplicate each other's work and often are at odds methodologically. So this set of issues was something that the data science team, as sort of really broad power users of the data, who were sort of answering questions from a bunch of different teams, was keenly aware of for the past several years. As just an underlying issue in the organization, we decided to finally go do something about it. And what we did was essentially we built this new team. So this is another example of a team spinning off of data science, and this is my main focus now, called Measurement Systems, that is specifically addressing what tools and infrastructure do we need to build, not just to enable people to use data, but to scale out how our company uses data to make decisions as efficiently as possible. So there's a couple of different components that are involved there. Number one, this is a bit theoretical, but I think the first problem to solve is knowledge representation. So if you have this rich organization that's collecting information sort of in a distributed fashion, different teams may represent the information about how people use their product in different ways, or may not collect everything that they want to collect. So if you pop up a level and you want to start asking questions holistically about how people are using Facebook across products, across the things we build, you find that typically the picture that we have is disjoint or incomplete. So the task here is to come up with tools for these individual product teams to more precisely and systematically and consistently represent what it is that they're capturing, and also identify the signals that span across product teams that are really important for us to understand and capture those as well. So it's sort of giving people richer tools for capturing data and thinking about the data sets that span our teams that are really important. So that's number one. And then the second problem sort of goes back to that example that I was giving with A/B tests, with a bunch of people building these A/B test frameworks. At a high level, not just with A/B testing, people at the organization do a bunch of different things in order to bunch of different analytic processes to extract information from data and use it for decision making. The main example would be A/B testing. That's something that everybody's doing. And what we want to accomplish is identify the cases where people are doing sort of similar things, and consolidate them and automate them into common tools. So with the A/B testing case, we've focused on building an experimentation platform. But I think more generally, what this set of work is about industrializing the process of data science. I think back to the first couple of years where I was a data scientist and I was doing a lot of analysis. And the work that I was doing was sort of humorously artisanal in a way. I spent a bunch of time extracting data on my own and playing around with visualizations and publishing a report and going up to a team and saying, here are the insights that I think are relevant for your decision making. I think there's obviously a lot of room still for doing that, but there are cases where that can be industrialized, the A/B testing example being an obvious one. So I think it's really, really important when you have a company that's trying to use data in this scaled manner to identify the cases where industrialization makes sense and then actually go off and do it, which is one of the things we're focusing on.
Terrific. So starting on another S-curve.
That's right.
All right, let's take 5 at most questions here. I know it's lunchtime. We're not only hungry for data, but also hungry. So any questions? Otherwise, we'll go to the lightning round. Yes, in the back.
Earlier you were talking about engagement and how to measure engagement, and when you look across, the population of Facebook users, not all users are exactly the same, right? So some users are able to create content for you; they're able to drive more content just by who they are and the connections they have. So just wondering how you look at that, and they can be doing exactly the same thing, two people posting exactly the same thing, but one person is going to have much more powerful effect than someone else. So if you could share any thoughts on that.
Yeah, absolutely. I mean, that's a really, really broad, rich topic. You're essentially highlighting the fact that the variability of usage is really, really high in a setting where you have a billion people interacting with rich social networks in a multitude of ways. I don't have a really crisp, definitive way to respond to that beyond just saying that we're really sensitive to these details, and that's, as I was saying several minutes ago, it's one of the reasons why we shy away from just looking at a single metric and a single measurement and a single statistic as the be-all, end-all measurement of what's going on. So it's important for us to understand the nuances between the different types of activities on our service, whether it comes to sharing content, consuming content, connecting with friends, finding jobs, whatever. And it's important for us to, be sensitive to the variability in people's experiences. So, as an example, we've done a lot of really great work trying to characterize how to identify differences among people in your personal network. So, you have this rich network of friends that, by and large, we represent in this very one-dimensional manner with this word friendship. But in reality, there's a huge variability of the people that you're actually connected to in terms of the relevance in their life to you, how well you know them outside of Facebook, how strongly you feel about them, what their purpose or usefulness might be to you. And that's something that we want to be sensitive towards and is something that analysis helps us understand. So I think the short answer to your question is we look at a bunch of different variables. We're very, very sensitive to distributions. And there's a lot of really interesting applied research problems about understanding the variability of people's personal networks and people's usage of Facebook.
Any other questions? One over here.
Yeah, related to your answer, because I think this is one of the key parts of the problem. How do you get people to begin to focus on not just a single summary metric or number or label, given the multidimensionality that you're talking about? And I'm seeing this over and over again because of the way media reports statistics and what happens. So it's more like what we want is a portfolio view of the world that's dynamic, and yet the public demands single numbers, single rankings, and single answers.
Yeah.
And this is a big, big problem, because otherwise we'll never get to the point of seeing, I think, the dimensionality you're looking at.
Absolutely. Yeah, it's really, really hard. That's a really good question. At our company, we benefit from a couple of different things. So, and in the setting of a company, I think you benefit from some things that you wouldn't if you're out in the public. So, number one, everyone wants to globally optimize. So everyone at Facebook, or I think by and large people at Facebook, are motivated to make Facebook really great, as opposed to just motivated to make their product and the 1 or 3 or 5 metrics that they're focusing on tactically moving really great. So I think that in the setting of a company, as long as you have the right culture, I think you can foster this desire for global optimization. And then the other thing that we benefit from is we use the same tools. And I think the tools are really where you change people's habits. So, if you have a tool that just focuses on the top level metrics, if you have a tool for, let's say, doing A/B tests where all it shows you is the 3 or 5 metrics that the company most cares about, then that's going to shape your experience of what you think is right. If you have a tool that only lets you specify the metric you care about, then that's sort of the flip side of it, where you're going to have sort of blinders to the bigger picture. So I think when you have a tool that emphasizes efficient consumption of information, but also you're able to efficiently see not just the things that you're trying to optimize on a day-to-day basis, but everything else that the company is looking at, then you can start to paint this more holistic picture. And that's essentially what we've done. I mean, just getting a little bit more into the tactics, we have this system where essentially every team can tag the metrics that are important to it, and then the tool that we use for A/B testing surfaces to you, if you're running an experiment, not just how your experiment affected the hypotheses that you had and the metrics your team cares about, and the overall top-level company metrics, but anything else that people in the company think is important. Now, there's a multiple comparisons problem and some difficult statistics associated with that, but the high-level picture is we're using a tool to sort of paint a broader picture as opposed to just focusing on your immediate goals. Yeah.
Are there like 127 of those, or how many?
Yeah, it's over 100. That's right. So yeah, you get into some multiple comparisons issues.
So which stakeholders were most interested in having that holistic approach? Is that something that the managers that are making those day-to-day optimization decisions about particular areas were really pushing for, or was it coming from other stakeholders?
It was coming from the fact that before we had this, there were many cases where, maybe not many, but there were a few pretty notable cases where one team would release a product that was clearly really positive for them, but it turned out after the fact hurt other people's metrics. And like I said, the culture at this company is one of global optimization. So as soon as you realize that, you essentially make the observation that as a company, we're not operating efficiently at all. We need something that gives us holistic perspective as to how the work of every team is affecting every other team. It's especially important in a place like Facebook, where you have a bunch of product teams that are not verticals and silos. It's product teams building stuff that is really, really interconnected. So the possibility for cross-product effects is really, really high.
Right here.
Who owns the tool revision, and how does that process go through?
What do you mean by revision?
So you say you have this tool. Now, I really loved your distinction earlier about sort of artisanal practices and industrial practices.
Uh-huh.
And if one assumes that the industrial practice, that the artisanal practices that end up with value potentially end up in revising some of the metrics in the tool, thus becoming essentially industrial and available to all. I love that distinction. I love that process that you talked about.
Yeah.
Who owns the updating of the tool, not just technically, but also internally, politically?
Yeah, sure. That's a great question. The honest answer to that is we don't have a really formal process right now, since we're sort of at the beginning of this process of industrialization.
So you do?
Yeah. So right now it's pretty much up to us to identify, up to the team that's building the tools to identify what are the best candidates for turning the artisanal into the industrialized. Which means that it's really important for us to keep really good connections and relationships with everything that's going on in the company, and keep really good connections with data scientists who are actually practicing this art, oftentimes artisanal, of building reports and doing analytics. I'll give you another example. So, as I said before, the main industrialization that we focused on is A/B tests, controlled experiments, because that is by far the most important way in which people leverage data to make decisions. But there's a class of products where that's really hard to do. And the most obvious example is native mobile apps. So our iPhone app and our Android app. Every time we build a new version of the app, it's not like we can A/B test that with the old version. We build a version, we ship it off to the App Store in Apple's case, and then people selectively choose to download it. But even though we can't do controlled experiments in this case, the teams have the same sorts of questions where they want to understand what is the impact of this product on metrics we care about. They want to do causal inference in the same way every other product team does. So in our course of just talking to teams, we observed that for mobile, what a lot of these teams are doing is sort of the obvious thing, which is some sort of before-after comparison appropriately controlled in some sort of manner. Now, that's a really interesting question. Like, what is the appropriate methodology there? And then how can we industrialize that into a tool? So we haven't solved that case yet, but that's another example.
All right, on the way out to lunch, if you don't mind, indulge us in the lightning round.
Yeah.
So, quick questions, quick answers. What's the coolest visualization you've seen recently?
It's called the triangle graph. It would be really hard to explain.
Should be a visualization, okay. What's the most interesting problem you've seen solved using data science recently?
Oh, man. That is not a lightning round question. I'll flip it around and say I think the most interesting problems I want to be solved with data science are around medicine and quantified self with respect to vitals. I think that's really interesting.
You answered this next question, so that's fine. If you were an academic researcher, what would you be working on?
Probably philosophy, to be honest with you. I have a passion for philosophy.
Maybe that's actually the answer to the next question as well. If you went back to college, what would you study?
Philosophy.
What would you be doing now if you weren't a data scientist?
I'm going to say studying philosophy.
Consistent.
I'm not sure, to be honest.
If you weren't working at Facebook, where would you like to work?
I'm pretty interested in this notion of industrialization that I've described, and I think that other companies need it, and there's perhaps an opportunity for turning it into an enterprise service. So I'd probably be doing something about that.
Industrializing industrialization.
That's right.
What company would you invest in other than Facebook?
Wow. I'm going to take the fifth on that.
Okay. What industry most badly needs data science that isn't really using it enough?
Back to my earlier point, I think it's health and medicine.
Who's the smartest or most interesting person working in data science today?
Wow. Off the record?
We are on video, just so you know.
At the risk of sounding like a fanboy, given everything I've said earlier, Jeff Hammerbacher is among the smartest people I've ever met.
Great, thanks. Let's go to lunch.
Yep.